Hello everyone, my name is Haoyu Wang. Here is the homework 7 on question 7. In the question, we know zt equal to n1t cosine omega t plus theta plus n2t sine cosine t plus theta, where theta is uniformly distributed in 0 to 2 pi, and n1t and n2t are widescreen stationary. n1t and n2t and theta are all independent. So first of all, we need to find the e to the zt. Because we know n1t and n2t are WSS, so we can get e to the n1t equal to nt equal to n1 and the same, and e to the n2t equal to n2. Then we can find the e to the zt equal to n1t cosine omega t plus theta plus n2t sine omega t plus theta. Then we do the calculation here. We know the basic concept of e, so we can put the separate these two. Then we can get e to the e of n1t times e of the cosine omega t plus theta equal to plus e to the n2t times e to the sine omega t plus theta. Then we do the we do the integral from 0 to pi cosine omega t plus theta d theta, and we take out the n1 times 1 over 2 pi. This all plus n2 times 2 pi do this integral from 0 to 2 pi, because we know it in the question is uniform distributed from 0 to 2 pi. Then we can get the integral from 0 to 2 pi sine omega t plus theta d theta. Then after we do this calculation, we find out it equal to 0. For the second question, we need to find RZ T1 T2 and figure out if ZT WSS. So in this question we get RZ T1 T2 equal to E from Z T1 times Z T2. Then we can get E n1 T1 cosine omega t plus theta plus n2 T1 sine cos omega T1 plus theta. So here is T1, sorry. And n1 T2 cosine omega T2 plus theta plus n2 T2 sine omega T2 plus theta. Then we can get R1 Rn1 tau times E cosine omega t plus theta here times cosine omega t2 plus theta plus n1 n2 E cosine omega t1 plus theta sine omega t2 plus theta plus n1 n2 e to the sine omega t1 plus theta cosine omega t2 plus theta plus Rn2 tau times e to the sine omega t plus theta times sine omega t2 plus theta. Then we do the calculation here. We can get it's 1 over 2 times Rn1 to the tau plus Rn2 to the tau. And then cosine omega tau then we can get R, then all is equal to RZ to the tau, which is RZ is WSS. For the question C, it's the same. We plug 0 into RZ tau, then we can get it's 1 over 2 times Rn1 0 plus Rn2 0. We can get its expression number 1 over 2 times e to the n1 to the t square plus expression number e to the n2 square t. The question 8, we get the Poisson process is defined by following properties. Then it was told these I was told by these properties and the graph. So we need to find the e to the xt. So first of all, we've done this before in the previous homework. We know for px equal to k equal to e to the negative lambda times the lambda to the k over k. This equal to this. Do the sum up from k from 0 to infinity, k e to the negative lambda times lambda to the k over k equal to lambda. Then we can get this equation. Also, if we do if we calculate the sum from k equal to 0 to infinity, k times lambda to the k over k, which is equal to lambda times e to the lambda. We do the derivative for both sides, then we can get the sum from k equal to 0 to infinity times k squared times e to the negative lambda times lambda to the k over k, which is equal to lambda plus lambda squared. Then we can get this e to the x squared minus lambda squared equal to lambda plus lambda squared minus lambda squared, which is equal to lambda. Then we can get e to the xt equal to lambda t. Then e to the xt squared, which is equal to 1 plus lambda t times lambda t. In the second question, we need to find out the RT1, T2. RT1, T2 equal to expression number x1, T1 times x2, T2. Then we can get this e to the xt1 times xt2 minus xt1 plus xt1. Then we times in, we can get e to the xt1 times e to the xt2 minus e to the xt2 plus e to the x squared t1, which is equal to lambda t1 times lambda t2 minus lambda t1 plus 1 plus plus lambda t1 times 1 plus lambda t1, which is lambda times t1 plus t1 lambda t2. And for t1 over t2, we can get rt1 t2 equal to lambda times t2 plus lambda t1 times t2. Then we can get r1 r2 equal to lambda, the minimum of t1 t2 plus lambda t1 t2.